All right, this is going to be the second video for Notes 32, dealing with solving quadratic equations by factoring. So in the first video, I got through parts A through F. Let's talk about G, H, and I. All right, so question part G, first thing I look for, is it equal to 0? And the answer is, of course, yes. Love that. Second thing I look for is, do I have a GCF? And also yes. Now, this GCF is a numeric GCF. So all of these terms are divisible by 2. So 2, I'm going to write down what's left over. So x squared plus 2x minus 15, right, still equal to 0. And I know this is still factorable, so I'm going to keep going and factor some more. Whoops, don't need more colors. All right, so let's see. Split this. All right, x squared is going to split into x and x. So I'm looking for what multiplies to negative 15 and adds up to positive 2. All right, so 5 times 3 makes 15. If I make the 5 positive, the 3 negative, that will multiply accurately. And 5 minus 3 is 2. Okay, good. It multiplies and adds up. Now, we have a problem here where we have 3 factors. Okay, we have our GCF. GCF was 2. And then we have the 2 factors that came from our lovely trinomial. Here's the thing. I've been telling you, right, first video, how do you solve these? You set each factor equal to 0. So I'm going to set each factor equal to 0, and I'm going to write down something right here that just makes my head hurt. But I'm going to keep going, all right? I'm going to write the other factors equal to 0, write the other factors equal to 0. Okay. I don't know about you guys, but the last time I checked, 2 does not equal 0. 2 will never equal 0. So this factor, while I can set it equal to 0, cannot actually equal 0. So this is not going to give us any kind of valid answer. The other thing you could look at for this one is there's no variable here, right? This is just a number equal to a number, and that is not a true statement. So ignore that. Just focus on the factors that actually do have variables in them. So this one, x minus plus 5, so I'm going to subtract 5 from both sides. So that's going to get me x equals negative 5. Put all the words in the right order there. And then x minus 3 equals 0. To solve that, I'm going to add 3 to both sides. That's going to get me x equals positive 3. So while I had 3 factors here, 1, 2, 3 factors, I'm actually only getting 2 answers. And that's coming from the fact that one of our factors, specifically the 2, this is a numeric factor. It's not, doesn't have a variable in it, so it's not going to have a solution for us. Okay. All right. So that's part G. I'm going to slide on over to part H here. And part H is actually going to be kind of a throwback to what we did in part A. So remember part A, we looked at this and we said, all right, we have x squared equal to something. And so what we're going to do here to solve for x, we are going to take the square root of both sides. So square and square root undo each other. That's the whole concept of inverse operations. We need to make sure that we are including a plus or a minus because we are trying to solve this for x. And then we've got the square root of 18. Now, we've been doing simplifying square roots for a while now. And so a couple different methods. You could, and I'm actually show 2 ways. You could simply say, well, the square root of 18 is really 9 times 2. Now you might be saying, well, why did you pick 9 times 2 and not 6 times 3? Well, the reason I picked 9 and 2 is because 9 is a perfect square. And so when I take the square root of 9, I just get 3 root 2. So that is my answer. Now I know a lot of you guys prefer to use the factor trees. Totally fine. Let's do the factor tree method. And so if I break up 18 and let's say it's 6 and 3, well, 3 is a prime number. If I break up 6, that would be 2 and 3. So there's all my primes. So I've got 2 times 3 times 3. And remember what I talked to you guys about. What you're looking for here is, in this case, because we're talking about square roots, is a pair. So you've got a pair of 3s. So we got 3. And then the thing that didn't pair up is 2. Oh, look, it's the same answer. Okay, so whether you do the factor tree method and you get 3 root 2, or you use perfect squares and you get 3 root 2. It honestly does not matter. You just need to get, by the way, the plus or minus part, and then 3 root 2. All right, so that's H, and then moving on down to part I. Okay, so we have a problem here. It is equal to 0. Love that. Is this factor, does this have GCF? And I'm going to kind of pause here and say yes, but also no. All right, now it doesn't particularly have a numeric GCF like a 2 or an X or anything like that. But the problem is I am not a huge fan of having that X squared be negative. So what I'm going to do is I'm actually going to factor out a -1 from every term, because that's going to make my X squared positive, and I am much more confident factoring when my X squared is positive. Do you have to do that? Absolutely not. Okay, but as far as factoring goes, as I just keep factoring while I'm talking here, that factoring method was a lot easier for me. All right, now that's just a personal preference. So I am going to pull out the -1, right? It changes all the signs on the inside. So negative x squared became positive x squared, negative 2x became positive 2x, and the positive 35 became negative 35. Okay, then in order to factor here, I was looking for splitting up my x squared, did that. Multiplying to negative 35 and adding up to positive 2, which is the normal kind of factoring we've been doing. Speaking of normal kind of stuff that we've been doing, we're going to take each factor, and I'm going to set it equal to 0. I'm ignoring the -1. If you want to see why I'm ignoring the -1, it goes back to that problem we did a couple times ago. -1 cannot equal 0, so that's not a solution. But I can solve for x by subtracting 7 from both sides. So x equals -7. And if I add 5 to both sides, all right, that's going to be x equals 5. All right, this is where I'm going to go ahead and cut off this video. So this is the end of all of the factoring problems in notes. I think this is 32, whatever notes I'm in. As always, ask me if you have any questions or concerns, please let me know, and I'll see you in the next one.